Saxon's Calculus, lesson 46, is about the integral of a constant and then integral of c, or a constant in front of an f of x function, and finally integral of x to the n. So in part A, it's the integral of a constant. And so they remind you, if you are doing the derivative of y equals 5x, that's going to derive to dy over dx equals 5. If you are doing the differential of 5x, you're getting dy equals 5 dx, because the differential has the dx attached with the answer, and then the derivative is where you have solved for it in its fraction form. And then they remind you that when we began to discuss integration, we learned that we needed to add that plus c to the end of it, which is adding a constant to each of the answers. So if it gives you the integral of 5, I was looking to see if it told me a letter. So if it just gives me integrate 5, then I'm going to make that 5 back to x as it had started here. So I'm just doing that mentally. And because it was the integration, I need to make sure that I put the plus c at the end of that. Now, they go into a discussion about moving a constant away, but I find it easier to deal with them all together in one. So I'm not covering more than this for section A. So if you're given just the integration of a constant, you're going to throw whether it's x or t or whatever the letter is that you're putting with it. Usually they'll say, because they want you to have a clue, but in this example they didn't say, and so you just need it with your plus c. Now, moving on to part B, the integral of a constant put in front of the function. And so what I'm trying to say there is constant and then the function signal. So flipping the page to 234, they ask for the integration of 4 with a 2x. Now, technically, if these were meant to be together, they would have said that this was 8x. So since they're two separate pieces, they're indicating that the 4 is a constant, and we should work it like so. So then, and before when we did integration, we were using a guessing. Now here is what my shortcut is when I'm dealing with not like the words cosine or sine, but when I'm dealing with numbers. Before, when we derived, we pulled our coefficient, the exponent off and multiplied it, and then we subtracted 1. So for integration, we want to do the opposite. We want to take the 1 that's here, we want to add 1 to it, making it 2, and then we want to divide that underneath. So we're doing exactly the opposite. And then, of course, those 2's will cancel. And so what I have here is a 4 with the x squared, and because I was integrating then plus c. So I hope that that is helpful then. In example 1, unfortunately, they go back to, they're still focused on this constant piece. So when they ask for us to integrate 4 cosine of t, we're picturing the 4 and then the integration of the cosine of t. So how do we get cosine? Well, that comes from sine, because when I do, I'm mentally checking it. Sine gives me regular cosine, because I got to be careful with those negatives. So yes, this will go back to 4 sine of t plus the c, because we always have that with our integration. Example 2 says, find the integration of the sine of u du. So sine comes from cosine. However, when I'm doing the mental check, cosine goes back to negative sine, and I need this to be positive sine. So I am actually having to negate the cosine of u plus my c. Now, they still treated this one as if it were a constant, because they're saying this negative that I'm putting here should be going in front. And I just feel like when they're dealing with this focused on it as a constant, it's causing more, not constant, coefficient, it's causing more issues than if I just think my way through it. Now in part C, we have the integral of x to the nth power. And so example 3 says find the integration of 5s to the negative 20th ds. Now, I'm going to do what I said I like to do as my shortcut, which is add 1 to the negative 20. That's going to give me negative 19. And then rather than moving this 5 in front, I know that I'm also dividing by negative 19. So I get 5 over negative 19 with my s to the negative 19th power, and then because it was integrated, plus c. Sorry, couldn't find their answer there for a split second. Yes. Okay, now, example 4. Integrate 1/3 and then the cubed root of t squared and dt. So before I can even do this part, I've got to fix this into its fraction format. So I'm going to leave the 1/3 alone, and then I'm going to turn this into t to the 2/3. This is the exponent, this is the root number. Now I follow my pattern of adding 1 to this, which is basically 3/3. So that's going to be 5/3. Now I have this 1/3 here that's going to be divided by that 5/3, and then that t, go ahead and add those together, 5/3. All right, so this needs to be fixed. This one is flipped and multiplied, so 3/5 gets multiplied up here. The 3's are going to cancel, so I have 1/5 t to the 5/3, and always r plus c. Example 5. Integrate 3, and they wrote this 3du in the numerator over square root of u. Now again, they are treating these as coefficients, which should be coming to the front side, but you can see how my shortcut is still just kind of putting it all together in one lump step. All right, so before I can actually do the integration, we're going to have to convert this, and that du should be at the end, but we're going to ignore it. So this is 3u, and then this is exponent of 1, root of 2, so 1/2, but it was in the denominator, so it's negative 1/2. Now I can integrate it by adding 1. So, let's change that to 2 over 2. So that's going to be 1/2 u to the 1/2. My 3 here was dividing by that same 1/2, so it's flipping and multiplying to 2 over 1. So that's going to give me 6 u to the 1/2 plus c. And then example 6 says integrate 5z to the pi. So I want to treat that exactly as I would z with pi plus 1, and then I'm dividing by that same thing, so I get this pi plus 1 in the denominator, and the 5 is still there, multiplying in front of this whole thing, and then my plus c. And I don't think they rearranged that to any other format. Nope. So the integration is just as easy if you're following that pattern of add 1 and then divide by that exact thing.